All right, lesson 8C. Still talking about rational functions and graphs. So topic 1.12 is transformations of functions. It says we can use the transformation rules for functions as a rapid method to graph and sketch rational functions. Let's recall the general rules before practicing. So remember that if you have something being added or subtracted at the end, it's going to shift it up that many units, or down if it was negative. If it's inside with x, it's going to go the opposite direction. So if it's x minus h, we're going to go to the right h units. If it's x plus h inside, we would go to the left h units. If it has a number in front of the function outside of the x, it's going to be the vertical dilation. Okay, if that number is greater than 0, it's going to, so let me write this here. So that number there for our absolute value of a is greater than 0, it's going to be a stretch. And if the absolute value of a is between 0 and 1, then it's going to be a compression or a shrink. And also don't forget, though, that if it's negative, that means it's going to be a reflection over the x-axis. And then we got, if x is being multiplied by something inside with the x, that's our horizontal stretch or compression. If this number here is, if the absolute value of that b is greater than 0, it's actually going to be a compression. And if the absolute value of b is between 0 and 1, it's going to be a stretch. Remember, it's going to be a stretch or compression by the reciprocal, okay? And then if it's negative, then the graph will also involve, it'll involve a reflection across the y-axis. All right, so before we actually start example 8, let's think about, I'm going to back up here. Let's think about the parent function for a rational function. Y equals 1 over x. Okay, we know that there is a vertical asymptote at x equals 0. We know there's a horizontal asymptote at y equals 0. Okay, for the parent function, there is no x-intercept and there is no y-intercept. But now remember, as we shift these graphs left or right, up or down, that can change, okay? And so the general one, our parent function, will look something like this when it's graphed. Okay, so it can change. All right, so knowing that, let's go on to example 8. So state the asymptotes and sketch the transformations, label key points. So this plus 2 right there is inside with the x. So that's our h value. And since it's a plus 2, we know that means we're going to go to the left 2. So my vertical asymptote, remember, I'm just going to sketch this in. Don't do this yet. So it was here at y equals 0, x equals 0. But if I'm going to go to the left 2, that's going to move it over to x equals negative 2. Okay, so what we're seeing is it's going to affect anything with an x value, okay? All right, so my horizontal asymptote was at y equals 0. Moving left isn't going to change that. But by moving to the left, though, there we can see now that we are going to have, so x-intercept's not going to change. But because we moved to the left, we do know we're going to have a y-intercept. And remember, you can just plug that in by, you can find that by plugging in 0 for x. So 1 over 0 plus 2, which is a 1/2. So at 0, 1/2 is going to be my y-intercept. And so I can plot that. We don't have any reflections or anything, so we know that this is going to be below on the left. And it's going to have to be above over here on the right, shaped by the asymptotes. All right, on B, we can see first, let's see that plus 1, which means we're going to go to the left 1. This is at the very end. This is that k value, which means we're going to go up 3. And this is a 2 times, because that's the same as 2 times 1 over everything. So this is going to be a vertical stretch. Oops, dang, sorry, I was trying to move my graph down a little bit here. So vertical stretch by 2. All right, so my vertical asymptote is going to go to the left 1, so it's going to be at x equals negative 1. My horizontal asymptote is being moved up 3, so it's going to be at y equals 3. my x-intercept, now I'm going to have to work a little bit more on this one, okay? Because it is those individual factors in the numerator. It's where my numerator is going to equal 0. But right now, my function is 2 over x plus 1 plus 3. I'm going to have to get a common denominator here. So that means that I'm going to, my common denominator, the easiest way is to multiply the numerator by the other one's denominator. So I'd multiply this first fraction by 1 and the second fraction by the x plus 1. So we end up with 2 over x plus 1 plus 3 times x plus 1 over x plus 1, which gives us 2 plus 3x plus 3 over x plus 1, which comes out to give us 3x plus 5 over x plus 1. Well, my x-intercept is going to be what's unique to the numerator. I don't have a factor the same on top and bottom, so it's just going to be the 0 of that numerator. So it's going to be where 3x plus 5 equals 0. Subtract the 5, divide by 3, and so we'll get x equals negative 5 over 3. So negative 5/3. 0 is going to be my x-intercept. And then my y-intercept, I'm just going to plug in 0 for x. So I'm going to work that up at the top here. So we get 2 over 0 plus 1 plus 3. So 2 plus 3, which is 5. So my y-intercept is at 0, 5. All right, so there's my y-intercept. Well, maybe if I get it to graph. Oh, cancel. There we go. Y-intercept is negative 5/3, which is like negative 1 2/3. So right in there. Horizontal asymptote up here at 3. Vertical asymptote at negative 1. All right, and then we can already kind of see because of where our points are. There was no reflection going on, so we know it's going to be the bottom left piece and the top right. All right, C. Minus 3 with the x, which means we're going to go to the right 3. Plus 2 means we're going to go up 2. And here we're going to reflect across the x-axis. All right, so my vertical asymptote was at 0, but now we're going to go to the right 3, so it's going to be at x equals 3. My horizontal asymptote was at y equals 0, but we're going to go up 2, so it's at y equals 2. X-intercept, got to go do some work. So let's see, so we have negative 1 over x minus 3 plus 2 over 1. So I get negative 1 plus 2x minus 6 over that common denominator. I just went ahead and distribute and put them over the common denominator. So it gives me 2x minus 7 over x minus 3. Nothing's going to cancel, so my x-intercept is going to be where that numerator is equal to 0. So at 3.5. My y-intercept is when we plug in 0 for x. So is that 1/3 plus 2? So we're at like 2 1/3. All right, so y-intercept at 2 1/3. X-intercept at 3.5. Vertical asymptote at 3. Horizontal asymptote at 2. And now we have been, don't draw this next piece, so we have been seeing our graph look like this, but now we got that reflection. So the bottom part's going to reflect up to the top, and the top's going to reflect to the bottom. And we can kind of see that because of these points here, the y-intercept here and the x-intercept down here. And then D. All right, so let's see. On D, this is 2 times x minus 2. So we can see that that 2 there, the 2 there is going to be a compression, horizontal compression by 1/2. Okay. The 4 means we're going to go to the right 4. And the minus 3 means we're going to go down 3. Now we got to think about the x though, anything that's dealing with x, because we have the shrink and the shift, okay? So our vertical asymptote, we're going to go to the right 4, but then it's going to shrink by 1/2. So really we end up just going to the right 2. So it's going to be x equals the shift 4, but times the 1/2. So we end up with x equals 2. Now my horizontal asymptote is just going to go down 3, so y equals negative 3. My x-intercept, I'm going to have to do like I did on the other two. So 1 over 2x minus 4 minus 3 over 1. Multiply this one by 2x minus 4. Multiply these by 1. So we get 1 minus, and we're going to distribute this, minus 6x plus 12 over the 2x minus 4. So I got negative 6x plus 13 over 2x minus 4. So it's our numerator equal to 0. So negative 6x equals negative 13. So x is 13 over 6, which is just a little bit more than 2. It's like 2 1/6. And so I'm going to go ahead and mark that while we're talking about it. So 2 1/6. All right, my y-intercept, plug in 0 for x. So 1 over 2 times 0 minus 4, and then minus 3. So 1 over negative 4 minus 3, so negative 3.25. All right, horizontal asymptote at negative 3. Vertical asymptote at 2. There was no reflection, so we know it's going to be the bottom left and the upper right. All right, so there's our graph on that one. All right, so now polynomial rational inequalities. And so we talked about polynomial inequalities a couple sections ago where we had to find those critical values. And those critical values were where my polynomial was equal to 0. So it's like the x-intercepts, but we didn't have to worry about vertical asymptotes. Well, now in these graphs, we also have vertical asymptotes. So if we look at this one, let's go ahead and look at it first, just as using the graph. So we want to solve the inequality where the rational function is greater than or equal to 0 using the graph shown below. So we want this to be, greater than or equal to 0. So we know that means where it's going to be above the x-axis. And so we can see that right here it's going to be above the x-axis and all of this. So we can see that it's going from this vertical asymptote right here at negative 3 all the way to that x-intercept right there at -2, and it's equal to union, and then from that vertical asymptote at +3 all the way to infinity, it's going to be above it. All right, now how could we find that, though, algebraically, if we didn't already have our graph? Well, I'm so glad you asked. So let's look at it. So we're going to go and we're going to have to find those critical values. And so our critical values are going to be where our numerator is equal to 0 and where the denominator is equal to 0. But now remember, you have to think about if you're going to use parentheses or brackets as well in here. The numerator will depend on the inequality. If it has an equal to, any number that comes out of the numerator will have a bracket. If it doesn't have an equal to, it'll have a parenthesis. The denominator can never equal 0, so it will always use parentheses, okay? So any number that comes from that denominator is always going to have a parenthesis next to it. So let's try that with this one. So we're going to go find those critical values. So we're going to set our numerator equal to 0 and our denominator equal to 0. So our numerator is x minus 2 equals 0, which means x equals 2. And because this has an inequality that has an equal to, we're going to use a bracket at the 2. Then we're going to set our denominator equal to 0. And so either we can just solve this like it is, or we could do difference of squares. But either way, we get x squared equals 9. Take the square root, you get x equals positive and -3. And because they come from the denominator, we're always going to use parentheses, okay? Then we can set up our number line like what we did in A. And so on this number line, it's going to have all three of these numbers. So it's going to have -3, it's going to have 2, and it's going to have +3. We're going to have our infinities. And then we're going to pick numbers in each interval. So -4, 0, 2.5, and 4. And we're just going to plug it into that rational function that we have there. So I'm going to do the work over here. So I'm going to plug in the 4, get 4 minus 2 over 4 squared minus 9. So that's 2 over 16 minus 9 is 7, so it's positive. And that's not right. I messed up. Oh, it's a -4. Excuse me. It's -4. All right, so that makes this -6. Sorry, which is negative. That's right. And I knew that because since they gave us a graph, I was able to look at the graph. But this is one of the reasons I tell you, don't just assume the first one's going to be correct and it should alternate after that. If I'd have done that, I'd have missed it all. All right, let's plug in the 0. So 0 minus 2 over 0 squared minus 9. So -2 over -9, which is positive. I'm not going to plug in the 2.5. I don't want to deal with a decimal without my calculator. So I'm hoping that this is going to fit my pattern. So I'm going to plug in 4. So I got 4 minus 2 over 4 squared minus 9, which was 2 over 7, what we had earlier, which is positive. And so by default, I know that that should give me a negative. And then because we're looking for greater than or equal to 0, we're looking for where it is positive. So I'm going to come over here to my number line. And I can see that it is positive right here from -3 to 2. -3 is always a parenthesis. 2 is always a bracket. And I can see it's positive right here from 3 to infinity. And we said 3 is a parenthesis and infinities are always parentheses. So we got the same answer algebraically as we did up here when we looked at our graph. Because they're not always going to give us a graph. All right, so let's look at example 10, because it wants us to solve this algebraically. And A is just a review, and it's just a regular polynomial. And so we're going to find our critical values, which since there's no denominator, we don't have to worry about that. So it's just set each of these factors equal to 0 and solve. And so I'm just going to call them CV, critical values. And so when we set this first one equal to 0, we'll get x equals 1. X minus 2 equals 0, we get x equals 2. And x minus 4 equals 0, we'll get x equals 4. And so remember, those are the numbers that we use on our number line. in numerical order. And we're going to pick numbers in each interval. So 0, 1.5, 3, and 5. And they're just going to plug it into our function and see what we get. Don't forget now, this has to be with a 0, and it was. And because it's equal to, that means we're going to use brackets. Okay, so brackets on all the numbers because they were all x-intercepts. None of them are from a denominator, okay? All right, so we're going to plug in 0. So when we plug in 0, we get -1 times -2 times -4, which is 2 times -4, so -8. All right, I'm not going to worry about the 1.5. I'm going to plug in the 3. So 3 minus 1, 3 minus 2, 3 minus 4. I get -2. And I'm going to plug in the 5. So 5 minus 1, 5 minus 2, 5 minus 4. And so I knew that this one should alternate. And so therefore, even though I didn't plug in the 1.5, I know it's going to be positive. All right, we're looking for where it's less than 0. What kind of numbers are less than 0? Negatives are, so we can see that our interval is from -infinity to 1 with a bracket, and from 2 with a bracket to 4 with a bracket. All right, B now goes into a rational function, but be careful, it don't have a 0 on the other side, so we've got to make it have a 0. So we're going to move the 2 over. So we get x plus 1 over x minus 3 minus 2 less than or equal to 0. Now to find those critical values, though, we're going to have to make this into one fraction. So this is like what we were doing on the other part. So I'll multiply the first fraction by 1 over 1, and the second fraction by the x minus 3 on top and bottom. So I get x plus 1 minus, I'm going to distribute this, minus 2x plus 6 over that common denominator. So that's what, -x plus 7 over x minus 3, less than or equal to 0. So my critical values are going to be where the numerator is equal to 0 and the denominator is equal to 0. So I get x equals 7. I'll look up there and it's got an equal to, so I know from the numerator it's going to have a bracket. X equals 3. It's from the denominator, so it's always going to be a parenthesis. All right, so set up my number line. My test intervals here, so we have 3 and 7. So I'm going to pick like 0 and, I don't know, 4 and 8. And so I'm going to plug that in. So -0 plus 7 over 0 minus 3. It's going to give me a negative number. -4 plus 7 over 4 plus 3. It's going to give me a positive number. And -8 plus 7 over 8 plus, that should be a minus 3. Don't know why I changed it to a positive. Either way, I didn't change that answer. This gives us negative over a positive, so it's going to be negative. We're looking for where it's less than 0, so we're looking for where it's negative. So -infinity to 3, which is a parenthesis, union 7, which is a bracket, to infinity. And then C, same thing, except it already has a 0 over there. So we're going to go ahead and find those critical values. So my numerator equal to 0 and my denominator equal to 0. X equals 3, and it's going to have a parenthesis because we don't have an equal to. And x equals -1, and it's going to have a parenthesis because it's from the denominator, and they always have parentheses. Set up my number line. Pick some x values and plug them in. So when I plug in -2, -2 minus 3 is -5 over -2 plus 1 is -1, which is positive. Plug in 0, 0 minus 3 over 0 plus 1, it's going to give me a negative. And plug in 4, 4 minus 3 over 4 plus 1 gives me a positive. We're looking for greater than 0, so we're looking for where it's positive. So I can see it's negative infinity to negative 1 with a parenthesis, union 3 with a parenthesis to infinity. And that is the end of lesson 8.